Hello, teacher. Hello, students. Welcome to today's lesson on circles. Last time, you learned how to write the equation of a circle. You also learned how to determine whether or not a given line and circle intersect. Today, we will learn more about these points of intersection. If you are ready, students, we will begin. In the last lesson, we discussed several results that may occur when calculating the perpendicular distance from the center of a circle to a line. If the distance of the line is less than the radius, then it is called a secant line. It has 2 points of intersection. If the distance is equal to the radius, then the line is called a tangent line, and it intersects the circle at only 1 point. These properties can be expressed by this relationship. A line with equation ax plus by plus c equals 0 intersects a circle with equation x minus h squared plus y minus k squared equals r squared if and only if the absolute value of ah plus bk plus c over the square root of a squared plus b squared is less than or equal to r. Let us suppose that we have a circle with equation x minus 1 squared plus y plus 1 squared equals 29. We also have a horizontal line, x equals 3. Students, can you find the intersection points of the line and the circle? I will give you a hint. You have the value of the x-coordinate. So now you must solve for y.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, everyone. How did you do? To find the intersection points, we can solve for y by substituting the value of x, 3, into the equation of the circle. We get 3 minus 1 squared plus y plus 1 squared equals 29. This gives us 4 plus y plus 1 squared equals 29. If we subtract 4 from both sides and take the square root of both sides, we get y plus 1 equals positive or negative 5. The 5 is positive or negative because the square of either number can be 25. So, the values of y are 4 or negative 6. Therefore, the points of intersection are 3, 4 or 3, negative 6. Recall that if the perpendicular distance from the center of the circle to a line is equal to the radius of the circle, this is called a tangent line. Let us work through a problem together. For the circle x plus 1 squared plus y minus 1 squared equals 13, a tangent line is y equals 3 over 2 times x minus 4. To prove this statement, we will use the distance formula to determine if the distance equals the radius. To use this formula, we must change y equals 3 over 2 times x minus 4 into the form ax plus by plus c equals 0. We multiply everything by 2 in order to get rid of the fraction and move all the terms to one side. We get negative 3x plus 2y plus 8 equals 0. From the circle equation, we determine the center to be negative 1, 1. We substitute these values into the distance formula, and the result is the square root of 13. From the circle equation, we know that r squared equals 13. R equals the square root of 13, which equals d. The line is a tangent to the circle. If we are given the equation of the circle and the point of tangency, then we can use this formula to find the equation of the tangent line. Y minus y0 over x minus x0 equals negative x0 minus h over y0 minus k. x0 and y0 are the coordinates of the point of tangency. H and K are the coordinates for the circle's center. Students, please use this formula to find the equation of the tangent line to a circle. X squared plus y squared equals 145. The point of tangency is 9, -8.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Let us review the answer together. Since the equation of the circle is x squared plus y squared equals 145, we know that the center of the circle is 0, 0. These are the values for h and k. x0 is 9 and y0 is negative 8. By substituting these values into the formula, we get y plus 8 over x minus 9 equals 9 over 8. In order to put this into the form of y equals mx plus b, we must multiply each side by x minus 9. This gives us y plus 8 equals 9 over 8x minus 81 over 8. To move the 8 over, we multiply it by 8 over 8 and subtract it from both sides. The equation of the tangent line is, therefore, y equals 9 over 8x minus 145 over 8. If you had any difficulties, please ask your teacher to look over your work after the lesson. Today we learned how to determine the coordinates for a point of intersection and how to write the equation of a tangent line to a given circle. In our next lesson, we will discuss parabolas. Until then, thank you, teacher. Thank you, students.